but it is not shipwrecks or ancient treasure they seek. Are searching for something far older. At depths that test the human body to its limits, they hunt for one of the most important zoological discoveries of our time. A living fossil that has escaped extinction for 380 million years. Now, an international team are heading into the abyss to meet this mysterious creature face to face. A survivor from a distant age that sheds light on the story of our own evolution. The coelacanth, a prehistoric fish that embodies a crucial chapter in the story of life on our planet. To enter the world of this dinosaur fish is to journey back in time. For nearly a century, the coelacanth has been the passion of scientists trying to understand the history and development of life on Earth. The fossils of these bizarre-looking fish have long been recognized as tantalizing evidence of a great evolutionary event. The day an aquatic creature first left the ocean to reach the open air and live on dry land. An event that millions of years later would lead to the birth of mankind. Believed to have been extinct for 65 million years, finding one of these fossilized fish alive would be like finding a living, breathing dinosaur. The fossil record shows that 500 million years ago, some soft-bodied animals developed spiny appendages that allowed them to take great evolutionary strides and conquer new territory. They formed the vertebrates, a family of animals which separated into two important branches around 380 million years ago. Some continued to evolve into the fish we know today, while others made the leap to dry land to gradually transform into amphibians, reptiles, birds, and mammals. The coelacanth appeared around the time of this major evolutionary junction.
The coelacanth is the most important zoological discovery of the 20th century. It had been known to 19th century paleontologists for a very long time. And they'd already determined, from fossils, that with the bones in its pectoral and pelvic fins, it resembled a transitional form between an aquatic and a terrestrial animal.
In 1938, a South African fishing boat made headlines around the world when it captured a live coelacanth. The fossil fish had suddenly come to life, and with it, the possibility of studying its strange anatomy, including fleshy fins that resemble limbs and a primitive set of lungs. In the 1950s, it created a frenzy among researchers. Captures of specimens for the laboratory increased, and scientists were able to examine these dead specimens for evidence of an evolutionary missing link. Studies conclusively determined that today's coelacanth is not the same creature that rose to the challenge of dry land. But research has shown that it is an ancestor of these animals, a distant forefather that has remained down in the depths, adapting itself to the abyss. In the stable environment of the deep sea, its appearance has changed very little in 380 million years, as if frozen in time. In 2000, a chance scuba diving encounter off the coast of South Africa brought man and coelacanth face to face for the first time without the need for a submersible craft. In 2010, another of these rare encounters from a depth of 120 meters was photographed and shown to the world. This feat was accomplished by deep-sea photographer and biologist Laurent Balesta. The extraordinary quality of his photographs and expertise in deep-sea diving is now leading to even more ambitious coelacanth research. With a team of French and South African scientists, Laurent is now planning a new mission in South Africa. By using scuba diving equipment to get close to the coelacanths, the team aims to take DNA samples without harming them, to study their mysterious peduncle fins with a specially developed 3D camera, and finally, attempt to tag a live specimen so that its migration patterns can be tracked. It has taken Laurent 3 years to set up 6 weeks of deep-sea diving research. Paleontologist Gaël Clément is joining forces with him for the expedition. Together, they have developed a new camera system that will break down every movement of the coelacanth's fins. This custom-built design is heavy and cumbersome, and they will need to deftly operate it 120 meters below the surface without scaring the fish. Focusing this dual camera system, nicknamed the giraffe thanks to its long articulated neck, takes hours of practice. For the perfect image, the coelacanth must be caught in the crossfire of 2 lasers. Laurent and Gaël hope that the images that they capture will allow the coelacanth's fin movements to be analyzed in 3 dimensions, shedding light on the form and function of these limb-like appendages. Laurent and his team are ready to attempt their first deep dive with the giraffe camera. Deep-sea diving has undergone a revolution with the development of new self-contained breathing systems that recycle exhaled air. The system is electronically managed and controlled by the diver, but even with such advanced technology, a diver can stay at 120 meters for just 30 minutes. They will have to make the most of this brief window of time to put into practice their new scientific techniques. The camera performed well and showed its potential to capture the images that the team will need for their research. But the team also want to discover more about the behavior, movement, and migrations of the dinosaur fish. To do this, they have designed an electronic tag that can be harmlessly attached to the coelacanth's back. This will monitor the depth, brightness, and temperature of the water for 9 months before detaching and floating to the surface. For over a decade, South African scientists have been sending down remotely operated vehicles to explore the Sodwana canyons in search of coelacanths. But using modern advances in scuba technology, Laurent aims to get much closer to their quarry and conduct experiments that even sophisticated robots are unable to perform. Peter Tim is an expert in locating one of the rarest and most sought-after fish in the scientific world.
Yeah, there's the Ushatska. Yeah, that's it.
Peter knows that the coelacanth is particularly fond of the caves formed over 20,000 years ago, at a time when the sea level was 120 meters lower. It was here in 2000 that Peter made the first scuba diving encounter with a coelacanth at a depth of 104 meters. Laurent's team will require his years of experience if they hope to pinpoint the areas of the rocky seafloor that might be home to coelacanths.
There is light. You see that there is a little bit of light?
Yes.
That means that the chimney is a sink.
The canyon they will be exploring is gigantic. Hundreds of caves offer endless potential hiding places, and the team will have only limited time to investigate them. these depths, every dive offers the chance to encounter species that have never been glimpsed by naturalists. But the search for a coelacanth will have to take priority. Elsewhere in the world, in the Comores and in Indonesia, coelacanths live much deeper, at around 300 or 400 meters. At those depths, only robots and submersibles can be used to find them. But the Sodwana canyons of South Africa are the perfect opportunity to meet them face to face. Nowhere else do coelacanths rise to 120 meters, and scientists have never dived so deep. It's as if each has made an effort to meet the other. April 2013. At Sodwana Bay on South Africa's east coast, an international team of scientists and deep-sea divers are preparing for the start of their 6-week search for the coelacanth. Five divers are preparing to spend more than 4 hours underwater, 30 minutes of which will be more than 100 meters deep. An expedition like this requires at least 2 boats, 3 rescue divers, and a lot of spare gas cylinders. Even for experienced divers, diving to such depths is extremely dangerous. It requires meticulous preparation and absolute focus.
Okay, Bob. Right.
Peter Tim first estimates the strength of the current, which can change each day. A buoy thrown overboard is monitored for 5 minutes by a GPS system.
How long, Bob?
4 minutes.
From these measurements, the speed of the surface currents can be calculated.
Done 100 meters in 5 minutes. So there's very little current, but it's going that way. So we'll drift from the deep water going to the shallow. The shallow is that side. So we're on the other side of the canyon now. We're normally that side, we're this side now. But the current will take us to the shallow water.
The team are ready to put 3 years of planning into practice. They face a tough technical dive into uncharted territory.
Okay, guys, on the word go, eh? Okay, 1, 2, 3, go!
The 5 divers immediately begin their descent to avoid being carried away by the strong surface currents. Like astronauts landing on another planet, they enter a universe 1,000 times more dense than our atmosphere and with 10 times the pressure. It will take just 2 minutes to reach 100 meters, but 4.5 hours to safely return to the surface. Their breathing mixture is gradually enriched with helium to prevent a feeling of drunken euphoria known as nitrogen narcosis, a dangerous effect of the pressure that can lead to carelessness and fatal lapses in concentration. The team arrives at the canyon. It's a huge area that may be home to very few coelacanths, and every minute counts. The search begins.
So the divers have just descended with their dual camera, the giraffe camera, to capture the coelacanths in motion. The purpose of these two high-resolution cameras is to study the subtlety and the complexity of the coelacanth's manner of swimming.
In an effort to explore every likely-looking cave and overhang, the team descend to 135 meters. But the deeper they go, the more their blood is saturated with inhaled gases, which greatly adds to the decompression time needed during the ascent. Laurent continues his search between 120 and 135 meters, and his efforts are finally rewarded. The cave holds two coelacanths. One emerges in a characteristic headstand posture. As the coelacanth eyes its bizarre-looking visitors, the giraffe camera films its movements from two angles, as well as in slow motion and in 3 dimensions. Lasers guide the cameraman, who must only start filming when the beams hit the animal's body. At 500 frames per second, each shot can only last for 4 seconds, so accuracy is crucial. Lobe-like fins and tail of the coelacanth are in contrast to the fine rays of the more common ray-finned fishes, which make up the majority of fish species. As it drifts with the currents, it uses them to stabilize itself and maneuver in virtually any direction.
The coelacanth's manner of swimming is extraordinary. First of all, because most of its fins are peduncular. That's to say, they are attached to the end of a little socket, which is covered with scales. And when you dissect these sockets, there are bones inside, just like the beginnings of arms and feet in terrestrial vertebrates.
The coelacanth does not seem disturbed by the divers or the bright lights of the camera, but the team know they have limited time with it. They have now been below 100 meters for 20 minutes, 12 of which have been with the coelacanth. Just 6 additional minutes at such depth will add an extra hour to the time they need for decompression on their return to the surface. it's the coelacanth itself that calls a halt to the dive by slowly disappearing into the abyss. The divers send marker buoys rocketing to the surface, but they will have to follow much more slowly.
Look, that's Thibaut's buoy. Everything looks okay.
23 minutes.
23 minutes, not bad. That means they had something to do down there. We'll have to wait a few hours now to get the whole story.
Well, now we're happy. All the buoys are up and there are no emergency signals. Now we just have to keep an eye on them.
30 minutes after the marker buoys come up, Sanri, an assistant diver, joins the team at the first decompression stop 40 meters below to check each diver's decompression time.
So we're happy. 5 boys, 5 divers down there. It's a relief. Now we have to wait to see what's written on the board. Because then we'll know if they saw the coelacanth or not, and if they managed to film it.
We're on borrowed time.
Absolutely, I'm on tenterhooks right now.
The scribbled note from the divers hovering below the boat looks promising.
I can see from their smiles that it's good news. Gambessa, yes, big, very big. Well, if he wrote big, very big...
It must be big, huh?
Exactly. Maximum depth, 114.
They must have spent the entire dive with it because it went back to the sandy shore. That's the best thing they could have hoped for.
Well, to dive.
It's so great to see it.
In fact, had I planned out, when you get in front of the cave, now I know at what depth you have to be to see it far enough ahead, and still be 5 or 10 meters outside. So I arrived, and I was well balanced. I still had my lamp shut off. I tried to get used to the darkness. I turned it down, and then, boom! I saw 2 eyes there at the back.
Back on dry land, the team examine the images from the giraffe camera. Marc Heban, an expert in vertebrate locomotion, joins Laurent and Gaël for the analysis.
So,
Yes, it's great.
do you like our shots?
They're great.
Really clear.
Really?
Really clear, they're perfect. There you've got the entire animal, you've got the movement in one shot, and in the other shot you've got the movement for the same fin.
Ah, that's great. There it looks like they work like oars.
Right, like oars. And everyone was just focusing on the 2 pectoral and the 2 pelvic fins, since they were supposed to be the feet.
The ancestors of our feet.
But nobody ever looked at...
The other 2 fins that are also peduncular.
Yes, and apparently from what we can see here and in all the images Yannick has provided us with, they're the most active ones.
The most active and the most flexible. The most mobile. It can really turn like a wrist in all directions.
For a stationary analysis, it's perfect. Next, if we could really get a lateral view of the coelacanth...
That's what we do now?
In an ideal world, but it's not ideal in these conditions.
Yes, especially at 120 meters.
That'd certainly be great.
Well, we'll go back tomorrow.
The dance of the coelacanth.
As the expedition progresses, the team are becoming more familiar with the canyon and complete more successful dives with the giraffe camera. But news has arrived that will move the expedition into a new phase. The authorities have granted the team permission to tag a coelacanth. Now, they just have to get close enough to the dinosaur fish to attach it. Sodwana Bay, South Africa, 2013. Laurent Balester's team have been granted permission to tag a coelacanth. The data the tag will capture may shed light on the secretive life of these ancient fish. But first, they have to find one and get close enough to attach it.
Go.
The team prepared to execute another perfect descent. But in deep-sea diving, nothing can ever be taken for granted. This dive proves to be their most challenging so far. Some awkward maneuvering is not the perfect start, and their frustrations continue. When a coelacanth is finally located, it's not in the correct position for them to complete their experiments.
We had to take DNA samples. We had to test whether the fish was willing to eat the bait we offered it. Plus, we had to use the giraffe. So, a lot of things to do. Too much protocol and too much underwater confusion. We didn't know whether to please the scientists or concentrate on the filming. We had so much to do, we didn't know what to think.
As a result, we were disorganized. We didn't really take advantage of the few minutes we had on the bottom. And in the end, we ended up with a lot of decompression stops and not much to show for it. Not much in terms of scientific experiments or filming either.
After an unsuccessful dive, 4 hours of decompression time feel even longer. But as the team reflect on the challenges that they face, they at least have some entertaining company. In this great oceanic desert, any floating object becomes a magnet for small creatures seeking food and shelter. As the hours pass, they attract more and more unusual visitors. A welcome distraction for tired, deflated divers. But the team cannot completely relax. They must monitor their equipment and are also being scrutinized by a silver-tip shark. The ancestors of this shark are as old as the coelacanths, and it's a sad sight to see one of the ocean's most majestic creatures trailing a fishing hook and line. The team usher it away, but their minds are soon back on the dinosaur fish. The water is becoming warmer, and that's not good news for the mission.
The water was too warm for the coelacanth. At 143 meters, it was still 24 degrees. There were no temperature layers, nothing.
It's not looking good for the end of the mission. Never mind. We'll see.
For the next 8 days, the exploration of the Sodwana canyons draws a blank. The underwater maps the team have been relying on to locate new caves are not leading them to new coelacanths.
The reason is okay.
To improve their chances, they turn to the latest multi-beam echo sounder, capable of giving them a much clearer glimpse of this invisible world.
We're in an area which is relatively unknown. Peter has a lot of experience. He's made a lot of dives, but he found spots by chance. He didn't really know where he was. With this kind of equipment, you can really clarify things and make a precise mapping of all the structures at the bottom. Here we have the result on this color gradient map, which is actually a 3D image. You can look at it flat, but you can also move it around to find all the caves, overhangs, etc. So there are several steps. There's the general mapping. We accurately mark the interesting spots. Afterwards, we'll send out an ROV and finally the divers.
Here we go.
The team's new approach helps them identify many new caves, but the coelacanths remain elusive. During the next 5 dives, Laurent and his team cover several kilometers of seabed. With the caves standing empty, the team instead collect water and sand samples. In the laboratory, scientists will be able to isolate any coelacanth DNA suspended in them to build the genetic profile of this prehistoric fish. But to complete their experiments, the team desperately need the coelacanths to return. There is only 1 week of diving left. The team has still not tagged a coelacanth, and now they are struggling to even find them. They need to find out if the warmer water has caused the coelacanths to leave the area, or whether they are simply using the caves at other times of the day. But they must hurry. Their last chance to discover more secrets about this enigmatic fish is slipping away. Laurent decides to attempt some covert coelacanth surveillance. A camera is installed in an underwater cave at a depth of 120 meters. For the next 5 days, it will take a picture every 10 minutes. If the spy camera reveals that the coelacanths are using the caves at specific times of the day, the team may be able to synchronize their diving schedule to the fish's routine. Five days later, the camera is retrieved.
The pictures are in. The moment of truth is near.
We're all with you.
It'll all start near the surface, I think. There's the cap.
The camera has steadily compiled images for 5 days, but a picture of a coelacanth is not among them.
No.
No coelacanths for 8 days. Theoretically, the water at 110 meters is too warm at the moment, 24 degrees, which is way too high for those depths. So we're waiting for changes to the underwater tides, so there will be colder water at the 110-meter level in the caves. But it's been 8 days, 8 days with no coelacanths. So it's very stressful waiting for the weather and currents to change.
As the last dives of the expedition approach, the dinosaur fish has disappeared. Still needing to gather more crucial data, Laurent and his team are feeling the pressure. The last day of the team's South African expedition arrives. This will be the final dive. The previous day, the water temperature at 120 meters cooled to 20 degrees, an encouraging sign. The team will target an area of the canyon where the coelacanths were last seen. The tag has been activated. Laurent must hope he will get a chance to deploy it.
This is it. If we can stop worrying and start concentrating, because there won't be a second chance.
1, 2, 3, go!
quickly descend. For 8 days, the coelacanth has eluded them. As they enter its twilight world for a final time, the team know that the next 30 minutes are critical to their success. This time, a dinosaur fish is there to meet them. The team finally have their chance, but they are on a tight schedule. There is just 30 minutes left to complete their scientific checklist and finally apply the tag. They begin by taking a DNA sample. A cotton swab on the end of a pole gently collects a dab of coelacanth mucus. The team hope that genetic analysis will reveal the relationships between different populations of coelacanths. A shadow passes overhead, a manta ray with a 7-meter wingspan. But the team cannot afford to be distracted from their task. As the coelacanth drifts out of its cave, the giraffe camera's lasers align to capture the perfect close-up and the twisting motion of its lobed fins. But the team still face their most difficult task. This is the first time a diver has attempted to tag a coelacanth. It's a delicate operation. After a careful approach, Laurent slides the hook of the tag between its scales. Startled, but with the tag attached, their dinosaur fish disappears into the abyss. For the next 9 months, the tag will record the movements of the coelacanth before detaching and floating to the surface to deliver its data. At the last gasp, Laurent and his team have achieved the expedition's final objective.
Here it is, right over there.
Ah, voilà.
They tagged it.
Non! Ils l'ont tagué!
There was one coelacanth, and they tagged it. Yes.
That's a really good
So there you go. Finished. But it's ending almost as well as it started.
It will take months or even years for the researchers at the Museum of Natural History in Paris to analyze all the data accumulated during the 6-week expedition. Scientists can now interact with coelacanths, and a new era in research has opened up.
Close up, it's really impressive.
Yeah.
You really feel like you're swimming with the coelacanth. See how it stabilizes itself.
These images can be transferred to a computer program that can simulate how the coelacanth swims. The technology will even be able to look through the scales and map the motion of the skeleton beneath. The complex mechanisms of the coelacanth's fin motion and synchronization will be revealed. It's a journey back through time, spanning 380 million years. And the researchers also have high hopes for the tag attached to the very last coelacanth encountered on the expedition. The data it captures may help us understand the behavior, movements, and migrations of this mysterious animal. To dive with the dinosaur fish was a childhood dream for Laurent Balesta. This challenging expedition into this extreme environment has fulfilled that dream and helped pave the way for an even deeper understanding of our oceans. Laurent and his team went in search of a legendary fish and found an entire ecosystem, a twilight parallel world just 100 meters from our own, where every second counts, but unforgettable encounters are still possible, and new discoveries could lie around any corner. In his quest for the coelacanth, Laurent Balesta also discovered and photographed 2 other fish previously unknown to science. A new world waits to be explored, in which more great discoveries seem only a matter of time.